So now we will do two programs, one using ALP and one using C, to see how you can go into a low power mode and then use an interrupt to come back to active mode, finish the work and go back to low power. Okay. So one more thing I wanted to say in the previous video while starting the LPM0, the current I had mistakenly said it as 800 microampere. It's not 800 microampere, it is 85 microampere. So please correct that. Okay, now coming back to this, we know what is BIS, that is bit set. Okay, so what do we have to set? We have bit set hash LPM3 bracket SR. So when you say hash LPM3, this LPM3 is already defined in your header file. That is why we can use hash LPM3. So if you go into your header file and see, you will have these definitions. You can see these definitions. So LPM3, you can see. So let's look at LPM0. You will have CPU off. So CPU off will be 1. LPM3 will be have SCG1, SCG0 and CPU off. All these 3 bits as 1. So these are already defined. You can directly use hash LPM3 or LPM0, whichever mode you want to go into. And your destination is SR, that is your status register. But this particular line, that is bitset.w hash LPM3, SR, has a problem. So the problem is that we should always be careful that, and we should always ensure that your GIE bit is set, that is your global interrupt enable is set. Why should it be set? See, you have gone into a low power mode. How do we come back? You cannot come back from a low power mode until and unless you are waken up by a external or a peripheral interrupt. Now, if an interrupt should come in, the interrupt enable should be enabled. Okay, that is your, and the global interrupt, especially if you're looking at maskable interrupt rather. Okay, it has 2 interrupt enables. One, it's its own interrupt enable. Suppose it is timer A, it's got the timer A interrupt enable. Okay, but beyond that, the first key is the GIE bit, that is the global interrupt enable in the status register. So we should make sure that GIE is also set. Okay, so this is how we will be writing in the program. So it is bis.w, that is bitset.w hash GIE or LPM3, SR. So GIE bit is also set, and the bits related to LPM3 will also be set in the destination register, which is the status register. Okay, so this you can see in the header files. Okay, so again, this also you can go and see in the header files how it is defined. So just have a look in the header files, just type Control F, type low power mode, low underscore power, and you can see how the bits are being set. So now going into the program, we will first look at the C program. Okay, so it's a C program to toggle LED in interrupt service routine user timing A. So that we have already seen. Okay, we have toggled LED using ISR. You toggled an LED using timer A. But now here the extra term or the extra constraint that we are doing is we have a low power mode. So we will be using low power mode. We will be in the low power mode. When that particular time is reached, let's say it's 0.5 second, the system comes out of the low power mode, goes into the ISR, toggles LED, goes back into the low power mode. So always in your exams, read the question properly. You have to see, is it just toggling an LED? Okay, or is it toggling an LED with timer A? Or is it toggling an LED with timer A and using low power mode? So you should read the question properly. Also, please make sure whether it is a C program or an ALP, because we are learning both C and ALP. So starting with hash include IO430x11x1.h. I've used 11x1.h because the same program we have implemented in the Proteus as well, and there the device used was 1111. So you can use any of the devices, just have to make sure that you include the appropriate header file. Hash include intrinsics.h. I had mentioned in the previous video, whenever you are using interrupts, you should use intrinsics.h as well, because the double underscore enable of interrupts is within the header file intrinsics.h. Hash define LED1 bit 3. That also we have seen. Bit 3 means only bit 3 is made 1. All the other bits are zeros. And that is defined as LED1. So whenever we use the variable LED1, bit 3 will be a 1. Similarly, hash define LED2 bit 4. Bit 4 is a 1. All other bits are zeros and it is assigned to LED2. We start the main program. WDT-CTL is equal to WDT-PW. That's a password. Odd with WDT hold. So you're holding the watchdog timer. You do not require the watchdog timer. Now what is P2 out? So we are going to connect the LEDs, okay, to the ports, and we will be connecting it to port. So here it is port 2. So let's not use port 2. When you're doing the program, I would suggest you do the program. You use port 1. So make all the 2's as 1. So you can use P1 out and P1 DIR instead of P2 out and P2 DIR. So it is negation of LED1. So LED1 is what? LED1 is bit 3 is 1. Negation of LED1 will be all the other bits are 1 except bit 3. So if you have connected two LEDs to 3. So instead of P2, I am telling it as P1. So if we have connected LEDs to P1.3 and P1.4, P1.3 is now 0. So that LED will not glow. And P1.4 is 1. So that LED will glow.